order of a reaction given we have some data. This is the experimental data that is given, that some experiment was performed, and this is the, let's suppose, the concentration of reactant at different interval of time. With this data I have to find whether it is a first order reaction, second order reaction, third order reaction. We have done a numerical for that also. So let's understand how to approach this kind of problems. There are three different ways to find the rate constant in order of a reaction given we have some experimental data. The first is the formula substitution. We have seen this kind of, we have used this in the past few numericals. You know the formulas of the first order reaction, second order reaction, and third order reaction. You can just try to fill in the values in the formula, and one formula which takes care of all these values, that is the correct formula, and the order corresponding to that formula will be my order of the reaction, right? So in this case it's a hit and trial method. Actually we will discuss about this. The next is the graphical method, and the third is half-life method. So the first is the formula substitution method. As I told, if you see, this is the formula for zero order, and this is for the formula of the first order, correct? If you want a little easy formula, then we know that for the first order formula, the reaction, the formula is K is 2.303 by T log of R naught by R. First order reaction. Zero, this is first order. Zero order reaction, the formula was K is nothing but R naught minus R by T. So here what we do is we generally try to plug in these values in the formula, because we know the value of T. Delta T is nothing but change in intervals, right? If you take this window, T is 30. If you take this window, again T is 60 minus 30. If you take this and this value, T is 60 minus 0 is 60. You take T and you have the initial concentration is R naught, final is R, depending on which window you take. And then you can find different value of K, right? Using the first order equation, if you get same values in both scenarios, that means it is correct. So in this case, what we do is we assume the equation to be zero order. We try to fit in the experimental values, and we try to find values of K for different set of results. If the value of K is consistent, I say it is zero order equation. If it is not consistent, we'll assume the equation to be first order equation. We'll try to fit in the values of the experimental data in this equation, find different values of K, different set of K, using different values from this data. If the values of K is consistent, we say it is a first order reaction. If not, again we cancel this, we assume it is the second order equation. We write the formula of second order equation. We try to fit in the values of these experimental data in this equation, try to find different values of K. If all the values of K are consistent, I say it is a second order equation. Correct? It's a hit and trial method. The next is the graphical method. See, graphical method, we know that if log of A versus T is a straight line, that means it is a first order equation. This is something which we have studied. If it is a second order equation, then my 1 by A versus T will be a straight line. If it is third order equation, then 1 by A square versus T will be a straight line. If it is a zero order equation, then my A versus T will be a straight line. So the first case, what we do, A is nothing but my concentration. We try to plot a graph between A and T. That is the most easiest form, right? This is A and this is T. If my graph is a straight line, it is a zero order reaction, done deal. If it is not, then I try to plot a graph between log of this value and T. If it is a straight line, it is a first order reaction. If not, again I redo things, start from the scratch. I try to plot a graph between 1 by A and T, and I keep doing it until I get the straight line. Correct? So with this, we'll draw different kind of graphs, and the graph which comes straight and corresponding to which scenario we have tried, which comes straight, that is my order of equation. If A versus T is a straight graph, it is a zero order equation. If log A versus T is a straight graph, it's a first order equation. If 1 by A versus T is a straight graph, straight line, it is a second order equation. If 1 by A square versus T is a straight line, it's a third order equation. Once I know the order of equation, I can easily find the value of K. I know the formula which I have to use. Correct? The last method is half-life method. And this is also used to calculate the rate constant order. So in this case, we know that for the first order equation, my half-life is independent of initial concentration. Correct? My zero order equation, my half-life is directly proportional to initial concentration, and for second order equation, my half-life is inversely proportional to initial concentration. This is something which we have seen. This is the fact we have seen, right? For zero order equation, half-life is directly proportional to initial concentration. First order equation, half-life is not related to initial concentration. For second order equation, half-life is inversely proportional to initial concentration. Now here also we do the same thing. We find the half-life for different initial concentrations, right? We find half-life for different initial concentration. Example, I'll assume this is my initial concentration. In the data, I'll try to find, if I have more data actually, where the concentration is half of this, and the time it takes. Directly I can see, right? Because that will have a time also. That is my half-life. Then again, I'll take this as initial data, and then I'll again take one more data where the concentration is half of this, because I'll have more data, assuming I have more data, right? I'll get time there also, because this time minus that time. Let's suppose I have data something like this. Let's suppose from this data, I have, this is 0.8, this is 0.6, this is 0.4, this is let's suppose this is the data. If I take this as my initial data, half concentration is 0.4, T will be what? 60 minus 0 is 60, right? T half is 60. Now if I take this as the initial concentration, and this is the final concentration, my T half is what? 90 minus 60 is 30. So if you see, the T half is dependent on initial concentration. That means it is not first order equation. In that case, this is the data, right? The T half, if you see, is dependent on initial concentration. I'm getting two different T half. It is not a first order equation. But now if you see, is it directly proportional to concentration or inversely proportional? If you see, here my initial concentration was more, 8, here is 0.4, right? So in this case, we have more data, here we have less data. I can say that T half is directly proportional to initial concentration, here, at least. This is not data. Please note, the data which I have is 0.4, 0.2, this data. So in this case, my T half has changed in both scenarios. This has more, this has less. Here my concentration was 0.8, initial concentration. Here my initial concentration was 0.4. So if you see, it is directly proportional, right? Concentration is more, T half is more. Concentration is less, T half is less. So T half is directly proportional to initial concentration. So I can say that looks like this is a zero order reaction. Looks like this is a zero order reaction. So that's how we do it using T half-life method, right? So the logic here is, if we have tons of experimental data with us, the time and the concentration, we want to know, is it zero order reaction, first order reaction? So we have three ways of finding it. First is a very crude way. We can just use different formulas, try to substitute the values, right? And one formula which gives a consistent value of K, that means that formula is correct, and then we say the order corresponding to that formula is my order of equation. Second is the graphical way. I'll just explain. We plot different graphs. If my a versus t is a straight line, it's a zero order equation. If log a versus t is a straight line, first order equation. If 1 by a versus t is a straight line, second order equation. If 1 by a square versus t is a straight line, third order equation. And the third is half-life method. We try to find half-life for different concentrations, different initial concentrations. And if I see the half-life is independent of the initial concentration, then it is my